All right, welcome back to Mr. Richmond's laboratory. Let's first go through the equipment that we have for the thermal energy from foods lab today. So you'll see that we've got back here, I've got the graduated cylinder. I have my beaker. I've already pre-measured 100 milliliters exactly of water and put that into here. Thermometer. It's suspended above the ground here. I've created a little canoe out of foil. I have a marshmallow on a skewer, and I have a triple beam balance, and then lastly I have my matches. So that's the equipment. I've already, as I said, preset some of it. If we were in class, you'd be building this yourself, putting this together, and then you'd be measuring out your 100 milliliters of water. But since we are ready to roll with this, I will be right back and we will start by getting our measurements. All right, so we are set. I've got my marshmallow set up here. We're going to set that on top of our triple beam balance, and hopefully you'll be able to see the measurements here. Our proper measuring, we're going to move this one first. It's much too large. We're going to then move this one over here. And 10 looks to be, wow, that's close, but it looks like it's a little bit too much. So let's go back down here and go all the way out here. This is looking like it's going to be pretty exact. The wind in the room is making it a little hard. I would say that's pretty close, maybe just back a little bit. Let's try right there. Shield it from the air a little. I think we're good. So try to get that measurement. I'll zoom in a little for you here. Now remember, your measurement is going out 2 decimal places for precision on this. And it may be hard to tell, but it's not quite to the 10. All right, we'll be back for part 2. All right, so at this point, you should have on your data table, on the 3rd page of the lab, the food filled in with marshmallow, the initial mass filled in that we just got, and now you'll be filling in the initial temperature. So that is what I am zoomed in on here, so that you can take that temperature. And then we are going to reset the camera, and I will be right back to film the burning of the marshmallow. So when this fades out, you should have food filled in, you should have initial mass, and initial temperature all filled in. All right, welcome back. We have our measurements now. So we should have food, marshmallow, initial mass, and initial temperature. I'm going to light the marshmallow and try to get it lined up right underneath. And as soon as that is done, we're going to zoom in and try to get a good reading on the final temperature, as the final temperature has to be measured quick because we don't want it to change on us. Then we'll cut away and I will recenter us and we'll come back and get the final mass of everything that is there. So here we go. So that didn't work. We got a little bit too much air in the room. I'm gonna have to take that out before we can measure mass. Let's try that one more time. So we're just going to let that marshmallow completely burn up down there. And it is officially out. So let's get recentered here and try to zoom in. Temperature. All right, so let's take a final temperature there. So let that settle. Takes a few seconds here for it to kind of just finish distributing it around. I would say we are probably pretty good. So take that final temperature reading. You should now have food, initial mass, initial temperature, final temperature, and we will be right back to get our final mass. All right, welcome back. We got our burned up marshmallow here. Let me get that set. And I have taken the match out that I messed up on. There's our burned up marshmallow. And now we know it burned up, so it should be less than it was last time, so I'm just going to go out and start somewhere up in here. Too much. So I'm going to come back. Bit more. Let's try that. That looks pretty good. So let me zoom in there for you. Remember, we're still going 2 decimal places. Okay. All right, so that should do it. You should have all of your information now. I want to remind you that when it talks about mass of water, we have exactly 100 milliliters of water. And the mass, you should be able to figure out because we know that the density of water is 1 gram per milliliter. And we have exactly 100 milliliters of water. Okay, so you'll be working through your calculations, change in water temperature, then utilizing that mass of 100 milliliters of water with the change in temperature and the specific heat on the first page of water to calculate the energy that went into the water from the marshmallow. And then you're going to figure out the change in mass based on your data table. And you're going to use those 2 answers to figure out the exact amount of energy, joules, per gram mass. So energy per mass, joules per gram, that the marshmallow had. and you're then going to convert that by following the directions into calories per gram. All right, so I hope you enjoyed. We'll see what the next lab is, and I'll be here recording that also. So get your work done. Have a good day.